Welcome to Mohan classes. In this video, we are going to discuss about irrational numbers and decimal expansion of irrational numbers. This is for 10th standard and part 3 session. It may be the last session for the real numbers. Let us start. So here we have to prove root 5 is a irrational number and 3 plus 2 root 5 is a irrational number. So before going to start this proof, we should know one concept. If P is a prime number which divides A square, then it can divide A also, where A should be a prime number. That is the concept here we are going to apply. Here now let us consider this root 5 as a rational number. Now we are going to consider this root 5 as a rational number. So root 5 is a rational number. Okay. So if root 5 is a rational number, it can be expressed as how? Root 5 can be written as A by B, where A and B are co-prime. What do you mean by co-prime? Co-prime means the HCF should be 1. So if you are simplifying it, you will get A is equal to root 5 B. Take square on both sides. A square is equal to 5 B square. So here A square is equal to 5 square. That means A square is divisible by 5. Correct? That means A is divisible by 5. If A square is equal to 5B square, A is divisible by 5. Therefore, we are going to take A is equal to 5C, where C is any integer. So if you are applying this, A is equal to 5C and A square is equal to 5B square, what will happen? 5B square is equal to 25C square. This, instead of A square, we are taking it as 5C whole square. That means 25C square. Here also, this B square is, will happen? B square is equal to 5C square. That means B square is divisible by 5 and B is divisible by 5. Here we are seeing A by B is a co-prime. Therefore, it should have only one as a HCF. Here 5 is also there. So it is contradicting our assumption, right? A and B have 5 as a factor. It contradicts, right? It contradicts our assumption. Therefore, root 5 is irrational. Clear? So here also we are going to take this 3 plus 2 root 5 as rational number. Okay, so that means 3 plus 2 root 5 is equal to A by B. So 2 root 5 can be written as A by B minus 3. That is equal to A minus 3B by B. Right? So root 5 can be written as A minus 3B divided by 2B. A minus 3B divided by 2B is a rational number. Okay. So that means root 5 is also rational number, right? So a minus 3b by 2b is a rational number, and root 5 also a rational number. Which is contradict our assumption. It contradicts our assumption. Therefore, 3 plus 2 root 5 is irrational. Here, so now let us go for decimal expansion. What is decimal expansion of a rational number? See, any rational number can be expressed in the form of a decimal expansion, right? So here, if the denominator of the rational number should be in the form of 2 to the power of n and 5 to the power of m. Whether it may be a single or it may be a product of 2 to the power of n or 5 to the power of m. It may be only 2 to the power of n or 5 to the power of m. If it is like that, then we can say that the decimal expansion will terminate. So here our question is, without dividing that numerator by the denominator, we have to say by seeing the denominator that ends with decimal expansion or non-terminating. Okay. So let us see the example here. 13 divided by 13 divided by 3125. Okay. So here we have to factorize 3125. 5. It will go with 5 because the last number is 5. So 6, 2, 5. Again 5. We will get 125. If we do with 5, we will get 25. 5 5s are 25. Now 5. So 3125 can be written as 5 to the power of 5, right? So therefore, this ratio can be written like that, right? 13 divided by 5 to the power of 5. So here the denominator ends with 5 to the power of 5. So it is the decimal expansion will be terminates. Here the decimal expansion will be terminate. Clear? Now, what about the non-terminating and repeating? If the decimal expansion is having some other prime number with power, or maybe multiply with some other prime number along with 2 to the power of n or 5 to the power of m, then we can say it is the decimal expansion will be non-terminating repeating. Let us see one example here. 77 divided by 210. Okay. Now let us do the factorization for 210. Here also we will go with 5, right? 42. Here 42 will go with 2. 21. 3. 7. 7. So here the denominator of this ratio 77 divided by 5 into 2 into 3 into 7. So 5 to the power of 1, 2 to the power of 1, 3 to the power of 1, 7 to the power of 1, right? So here we are having some other prime numbers, 3 and 7 along with it. So for this 77 divided by 210 is a decimal expansion of non-terminating and repeating. So without doing the division by long method, we are simply declaring by doing this prime factorization of the denominator and saying whether the decimal expansion is terminated or not terminating or repeating. That's it. Hope you have completed the real numbers. I think everyone has understand what is real numbers. If you have any doubts, you can come up into the comment section. Thanks for watching. If you like this video, please subscribe and give your likes. Thank you.